Today, we will be talking about the life of Lise Meitner. We broke her life into 3 separate parts: academic career and achievements, scientific discoveries and contributions, and legacy and influence. Lise Meitner was born November 7, 1878 in Vienna, Austria. She was the third of 8 children of a large Jewish family. Because girls were not allowed to obtain a higher education during this time, her family got her a private tutor when she was 14. In 1901, she attended the University of Vienna, where she studied physics under Ludwig Boltzmann. She obtained her doctorate in physics in 1906, becoming just the second woman from the university to earn such a degree. Meitner went to Berlin in 1907 to study with Max Planck and the chemist Otto Hahn. She worked with Hahn for 20 years, with each of them leading a section in Berlin's Kaiser Wilhelm Institute for Chemistry. They worked closely alongside of each other, studying radioactivity with her knowledge of physics and his knowledge of chemistry. Meitner held several academic positions throughout her life, including professorships at the University of Berlin and the University of Stockholm. She spent most of her scientific career in Berlin, Germany, where she worked as the first female full professor of physics and became a department head at the Kaiser Wilhelm Institute. Unfortunately, she lost these positions in the 1930s because of the anti-Jewish Nuremberg laws of Nazi Germany. Instead, she fled to Sweden, where she continued her work. Despite facing discrimination and obstacles as a woman in science, Meitner received recognition for her achievement. She was nominated several times for the Nobel Prize in Chemistry and Physics, though she never received the award. Nevertheless, she was honored with various other accolades for her contributions to science. These accolades include, but are not limited to, the Lieben Prize from the Austrian Academy of Sciences in 1925, the Max Planck Medal of the German Physical Society alongside Hahn in 1949, the Otto Hahn Prize for Chemistry and Physics in 1954, and the Enrico Fermi Award in 1966.
Scientific Discoveries and Contributions by Lise Meitner. Meitner is best known for her crucial role in the discovery of nuclear fission, which occurred in 1938. Hahn was the one who isolated the evidence for nuclear fission, but Meitner and her nephew Otto Frisch were the first to articulate how the process occurred. This discovery and Meitner's recognition of the explosive potential of the process was what motivated Leo Szilard and Albert Einstein to contact President Roosevelt, leading to the establishment of the Manhattan Project, which Meitner declined the invitation to work on. More specifically, nuclear fission is when a uranium atom splits due to being bombarded with neutrons, and the split causes a large release of energy. Radioactive contributions. Meitner and Hahn investigated the radioactive decay of uranium and thorium, which later aided in their naming of nuclear fission. Meitner also did research relating to nuclear isomerism and beta decay. Nuclear isomerism is a condition in which the atomic nuclei with the same number of neutrons and protons have different lifetimes. Beta decay is any 3 processes of radioactive disintegration by which some unstable atomic nuclei spontaneously dissipate excess energy and undergo a change of 1 unit of positive energy without any change in mass number. Meitner and Hahn were eventually the first to isolate the isotope proactinium-231. The discovery of proactinium-231 was separated from uranium or pitchblende, a much more stable isotope with a half-life of 32,500 years. Proactinium itself is highly radioactive and used mostly for research purposes.
Meitner's accomplishments have inspired countless women to pursue careers in science and overcome gender barriers in academia. Her perseverance and dedication helped serve as a beacon of hope for aspiring female scientists around the world. During her years as a scientist, she campaigned for equal opportunities for women in academia. She did this by speaking out against discriminatory practices and by organizing gatherings aimed at promoting the work and research of female scientists. In her later years, she spent most of her time traveling, where she would encourage women to enjoy and pursue science. Eventually, she even had dinner with President Harry Truman, who was an attendee at the Women's National Press Club, where Meitner was named Woman of the Year. Her discoveries have had a profound impact on both scientific research and technological advancements. Her research laid the groundwork for the development of nuclear energy, nuclear reactors, and nuclear medicine, but many also fear the non-peaceful uses of this energy. Some of the peaceful uses include nuclear power generation, which creates electricity through a reliable and low-carbon manner, and medical applications such as radiation therapy, CT scans, and sterilization. On the other hand, many problems would also arise due to this new nuclear energy as well. Many nations were frantic and took off in what we know as the nuclear arms race, which heightened tension between each nuclear-armed nation. There was also a concern with the disposal of radioactive waste generated by nuclear fission, which subsequently would create environmental hazards. Overall, Meitner's research shows the dual nature of scientific discoveries, as it can be used to benefit or harm others.